Hey guys, we're going to start today. This is going to be a review of what you looked at last week in terms of acids, bases, and a couple of things about pH and indicators and how we use that. And so just a couple of things I want to very quickly review with you. First of all, let's talk about the Arrhenius definition. And that's just a quick definition of what is considered to be an acid and what's considered to be a base. An acid is something that when it dissociates, and that just means when you put it into a water solution, it breaks apart, you're going to produce ions. And one of the ions that we're looking at is hydrogen. And so any substance, if you have the chemical formula and you see that it starts with hydrogen, and you recognize that it's an ionic substance, when it dissociates, it's going to produce hydrogen ions, is considered to be an acid. And likewise, Arrhenius said that bases were substances that when placed in water dissociate to produce ions once again. But one of the ions that we're looking for that makes it a base is the hydroxide ion. Okay, so if you look at a chemical formula and you see that it ends in OH, then chances are that's going to be a base. So this is a very limited definition of acids and bases. So one of the ways that you can identify acids and bases is by looking at their chemical formula. Okay, and that was something that you've been practicing the last few weeks. The other thing that's really important in identifying acids and bases beyond their chemical formula and their properties is the pH value. And so looking at the pH scale, one of the things that you kind of practiced on in terms of the lab was understanding that the pH scale is just a numerical scale that goes from 0 to 14. 7 is a place mark on that scale that's important to us because we recognize that anything that has a pH of 7 is considered to be neutral. And what that means is that the hydrogen and hydroxide amounts are equal. Now, pH kind of is used to indicate the amount or the power of hydrogen. And so looking at these numbers, we use the numbers just to indicate not only whether or not something's an acid, base, neutral, it also gives us an idea of the strength as well. Strong acids are going to have very low pH values, like 1, 2, 0. Strong bases are going to be at the other end of the pH scale, and they're going to have higher numbers like 12, 13, 14. Right in the middle, pH of 7 is something considered to be neutral. And so in the labs, you looked at several different kinds of examples of different substances, and one of the things that you did was to use a pH meter to just measure the pH value. So anything from 0 up to 7 is considered an acid. Any substance that has a pH above 7 up to 14 is considered to be a base, and that's alphabetical, A, B. Okay, so if you have a pH meter, then you can measure the actual amount of hydrogen that's present in the substances. Next week, we'll talk, the following week, we'll talk a little bit more about pH. Now, we don't always have a pH meter handy to measure those. And so another way that we figure out whether something's acidic or basic or neutral is by using something called an indicator. And indicators can be man-made, they can be synthetic, or they can also be natural. And so in the alien juice bar, you were using red cabbage juice as an indicator. And of course, red cabbage comes from a plant, so that's a natural indicator. Pretty much any kind of vegetable, fruit that you look at, the skin, the flesh of the fruit, if it has color to it, it can probably, it has pigments of some kind to reflect that light, and those pigments often will change shape in the presence of an acid or base and can be used as an indicator. So red cabbage does just that for us. Now, it's important to note that on the pH scale, what are the colors indicated by red cabbage? Because in the lab, you figured out it's not the color of the substance that we can use to indicate whether it's an acid or basic. You know, Sprite is clear, okay, but it's still slightly acidic. Whereas Coca-Cola is dark brown. Orange juice is orange, so you can't use the color of the substances. It's important to use the color of the indicators. Those two things are not the same thing. So in talking about using red cabbage juice, acids are going to be pink. If something is neutral, you should have found out that that's purple. And if something is a base, it's going to be green in color. And so one of the things you did was just to look at adding red cabbage to see what color substances changed with the indicator. The indicator would give us an idea of the strength and whether or not it was an acid or a base. Now, there were a couple other things in the lab that I wanted to kind of go over real quick that you should have found out. One, of course, is how we use indicators to indicate pH. But one of the other things that you should have understood is that the amount of the substance does not influence the pH. Here's what I mean by that. If you had a container and we had orange juice, say, and let's say that we put in 10 milliliters of orange juice, and that same orange juice we put in a second container and we did 100 milliliters. The pH of those two substances, because they're the same substance, would be identical regardless of the amount. However, the other thing that you found out is that when you add water to something, and you add water and you dilute the substance, that does change the pH. Now let's talk about real quick what happens when you add water. We know that water is neutral. When you're adding water to a substance, what you're essentially doing is you're diluting that substance. Now, here's what happens. For an acid, remember, if we were to look at this solution, what we would see would be, on the ionic level, lots of hydrogen, very little, if any, hydroxide, and then we'd also see some water molecules present as well. Now, when I add water to that, what that's going to do is it's going to change the overall volume, and we're adding and spreading out the particles that are already there. So by adding water, okay, and we're changing the amount, we change the actual volume, and we increase that volume of the solution, what that does is it decreases the amount of hydrogen. And so something that, like orange juice, that may have a pH of 3, as you add more and more water and you dilute it, the pH is going to begin to rise and it comes closer to being neutral. And so we might say that adding water to an acid will cause the pH to rise. And what that does is it actually decreases the acidity. Okay, so it actually moves closer to 7. Likewise, if we take a base and we look at a base substance, let's say instead of orange juice, we were talking about something basic. Ooh, toothpaste. Ugh, I think that was one of the things that you had on Alien Juice Bar. Toothpaste juice. Ugh, I'm not really sure. Oh, anyway. We all know that toothpaste has kind of that, a little bit of a bitter taste to it, right? That pasty taste. And so toothpaste is slightly basic. What that means is when we look at it, we would expect to see a lot more hydroxide mixed in with the water and very little hydrogen. But the same idea, if you add lots of water to that, what that does is it dilutes down the amount of hydroxide that's present. And so one of the things that it does is that the pH is going to lower. And once again, you're going to move closer to 7 for it being neutral. And so adding water dilutes. So if it's an acid, it's going to move it closer to 7. If it's a base, it's going to also move it closer to 7. One of the other things that you did in the Alien Juice Bar that was kind of fun is you ended up changing the pH. And so you kind of played around with what happens to the pH. How can you change something? Like, for example, if you started out with an acidic drink and your alien wanted it to be basic. How did you get it to become basic? And so what you're doing is you're moving it along that pH scale. And the best way to do that is if you have an acid and you want it to become more basic, then you've got to change the concentration of the hydrogen by producing more or adding to that more hydroxide. And so if you want to make it more basic, you got to add base. And of course, different substances have different strengths, so it kind of depends on what you chose to add. And you may have noticed that sometimes you had the pH change a lot, sometimes it changed very little, depending on the amount of hydroxide and the strength of that base that you were adding. Likewise, let's say if your alien, if you started off with a basic drink and they wanted to change it and they get more acidic, then of course what you've got to do is add an acid. And adding an acid, if you start off on this end of the pH scale, brings it back down. Kind of interesting. So how would that work? Let's say if we started off with something like pure water, which is right smack dab in the middle with a pH of 7. And what if you wanted it to be more acidic? What would you add? Well, more acid. All right. So Alien Juice Bar was really just about practicing through understanding some things about how adding solutions, whether you're diluting it down or you're adding something acidic or something basic, and how that changes the overall pH. Hopefully after reviewing through this, what I'd like for you to do is the quiz is open. You can go back, and if you need to change any of your questions, then certainly do that. And by changing those questions, I'll be grading those and entering those grades later today. You should also make a note that by the end of the day today, I'll probably have dropped your lowest lab/quiz grade in that category. So you may see some changes in your grade, so check those out. If you have questions, let me know. And don't forget, tomorrow we're going to be talking about acids and bases some more. We're going to look at the Bronsted-Lowry definition, and we're going to look at conjugate acids and bases. It's a little confusing, so we're going to do that as a virtual lesson. So make sure that you chime in for that. I'll see you guys later.